that's all about that question. Now 5.2.3, it says now write down the minimum value defined by this function. So for the minimum value, we are saying we are working with the function of y is equals to, remember we know that this already, we're told that this is equals to what? This is equals to 1 minus sine x. Now, when you're looking at this 1 minus equals to 1 minus sine x, so the minimum value in this case, it will be 0, because this is just going to be our normal sine x. So that means you can now think about a normal sine graph first. When you think about a normal sine graph, you have it. It goes like that. So that's how we interpret this question. This is 90, 180, 270, 360. So that is our normal sine graph. When we rearrange this, we have something like y is equals to negative sine plus 1. Right. So what does it mean now? The negative sine x, it means now we have to do what? We have to reflect this about the x-axis. That means the new graph, this graph that we're having, it will go like this. So it will go in that way. So that is the graph that we're having here. But it says plus 1. So I must effect this shift. When you say plus 1, we'll shift this graph 1 unit up. Remember, this is going to be negative 1, and this will be 1. So when you shift this graph we're having, so what, this is the graph that we're going to obtain. When you shift it 1 unit up, so this one is going to come here, this will come here, this will go up here, and all of this. So what we'll have is, it will now start at 1, 0, with negative 1. So it will now start here, the 90 will be shifted again. So our 90 here, then we have 180. 180 is no longer at 0, it will be at 1 now. So it's going to go like that. Then the 270, it was at 1, it will go to 2. Then the 360 will come back to 1 now, because we're shifting 1 unit up. So remember, this is the shift that is happening about the y-axis. Remember, y is equal to a sine k into x minus p plus q, where we are saying the q, it is our q in this case is our vertical shift. So that's why I'm shifting it above that. A, it affects our a in this case is negative, so we're just gonna flip it and make it flip it around or reflect it around the x-axis, and we now know that our q in this case was plus 1, and there's no shift around the horizontal. So now when we shift it 1 unit up, so it's gonna move like that. It's gonna go up there. Oh, the 180 is it's gonna go back to 1. So this is back to 1 and 1. So the minimum value in this case is 0, because the lowest point now is 0, which is at 90 then. So that is where the minimum value is in that case. Another way you can do it, you can just use this in this case. What you can do now, you can now say y, we have it's y sin theta, then you transpose the theta to the other side. So you have sin x is equals to 1. It's going to be negative 1 and 1. Then the reference angle here is going to be 90. Then you can now find that our minimum is going to be 90 when you do the resolution of that. So what we do now, just shift it 1 unit up. When you shift it 1 unit up, the minimum value there is 0. Right. Now, this is 5.3. Now, in 5.3, it's a bit of a challenge. So I will give you 10 minutes to complete 5.3. Right, welcome back, Richard. Now, 5.3 says, you are given that cos A minus B is equals to cos A cos B plus sin A sin B. Use the above identity to deduce that sine into a minus b is equals to sine a cos b minus sine a sine b. Sorry, cos a sine b. So what are we supposed to do? So we are given this. So we are now supposed to do what? We are supposed to deduce this identity in this case. Now let us look at the solutions to this. Now, how are you going to do it? Number one, we're going to use co-functions. So we're going to use co-functions because as we are using co-functions, we now know that our cos, our sine a minus b, it is the same as sine a minus b is the same as cos 90 minus, so I'm going to consider the whole thing as a unit, minus into a minus b, which is what I did here. It's the same thing because the co-function of a cos 90 is going to give us sine. If we reverse this back, this will now give us sine again. It will just be what? Sine into a minus b. So that is what's happening in this case. So what we do first, you now say, all right, sine a minus b, it is the same as cos 90 minus a b in that case. So that's what we're having. So what we do from there, we just distribute the negative there nicely. Then we now have, when I distribute this negative, what am I going to have? I'm going to have cos into 90 minus a plus b. However, I need to write it the way it was written before. So I'm going to say it's cos of 90 minus a. Now, to have b again, so what am I going to do? To remain with this b, as it is positive, I put a negative and a negative b. So the negative and negative still gives me the positive b. So I haven't changed anything in that case, which is what I have done in this case. For what we do in that case, we just say, okay, 90 and a, we want to consider the 90 and a as a single angle. That's the a. Thereafter, we don't want to change b. We want b to remain positive. However, we are working with a negative one, so we want it to get a negative sign. That's why we introduce the negative sign in that case. Thereafter, we now apply this which is given to us. Now, a minus b, so this alone, I can say this is my a, and this is my b. So those are the angles a minus b. So this is my a, this is my b. Thereafter, it's equals to, remember, it was equals to cos a. What is a? A is 90 minus a in this case, which is what I have there. Multiply by b. What is b? Cos b is cos b here. So the cos b, it becomes what? It becomes negative b because our b in our equation here, it is negative b. Then we proceed plus the sine. We have sine a. Sine a, remember our angle a. This is important. Our angle a is 90 minus a. Our angle b is negative a. So that's what we have in that case. So this is just as simple as that. Whenever there is b, so in this case, from this equation here, so what we did, it was simply cos a times cos b plus sine a times sine b. Just that our a is 90 minus a in this case. From this one, our b is negative b. Our a again is 90 minus a. Our b is just negative b in that case. Now what we do there, we now say cos 90 minus a. We go to our Cartesian plane. Check 90 minus, it means cos is positive. Then the cos, because at 90 it's going to change, becomes sine, positive sine. Then we proceed. Cos into a negative angle is just a positive cos. You know that, right? Because cos into a negative angle, it goes to 360, and it goes from the 360, it goes below that, and cos is positive in the fourth quadrant. So it goes into the fourth quadrant. When we change in the direction, which is now, we are now going to measure clockwise, it becomes positive cos. Then we proceed. Sine 90 minus a. 90 minus is this side. Sine is still what? Positive. Then this sign will change to cos, then it becomes a positive cos a. then sine into a negative angle, it's a negative sine. So sine into negative b is a negative sine b. So that's what we're dealing with. Then what thereafter, what we do, just say write it as it is, which is now sine a equals b minus this minus will multiply with the plus cos a sine b, which is now the rule that has been introduced. Right. Let us look at number 2. Now they say hence or otherwise determine the general solution to this equation. Now remember one thing, retrieves. When we are dealing with the identities, we know that we can say cos, well, let's just use the sign. When we're saying sine A minus B is equals to sine A cos A minus sine B cos. Okay, I'm just going to write this again. This is not enough. So this means from identity sine A minus B, it's the same as sine A cos A minus sine B cos B minus sine A cos B. So it is the same angle in that case. So the only thing that we're doing now is this side is just cos A, but the angle is changing, sine A. Right. So remember, we can move from this side to this side, and we can equally move from that side to that side. So we can interchange the sides in this case. So what can we do in this case? We can proceed and say, okay, so what we can do in this case is the following. We can group this to become a single compound angle. So it becomes, remember, it's a minus, it's a sine and a cos, sine and a cos. Remember, with the sine and cos, what's happening? The angle is changing, the sign remains the same. So this is sine into 48 minus, so that's what we have there, sine 48 minus x. It's equals to what? It's equals to cos 2x. It is important for us to do what? It is important to make sure that the angle it becomes the same. When we say the angle becomes the same, we're saying the functions, not angle, the functions become the same. So we can change this cos and make it sine. We're using the cofunction. We're going to say 90 minus 2x is equals to our x in this case. So what we now have, in this case, we'll now have the following. We'll say add sine to both sides. We'll have 48 minus x is equals to 90 minus 2x. So this is going to be our theta is equals to this our reference angle. Our reference is 90 minus 2x. So what we do now, we now use the general solution of sine. So our general solution of sine in this case is what? Remember, we have two angles, it's theta, it's equals to reference plus k times 360. And we have another one, it's theta, it equals 180 minus the reference plus k times 360. So that's what we are doing in that case. So that means our theta is 48 minus x. Our reference is 90 minus 2x. Now, this is what we have in the following first one. The first one is this one. So our theta, our reference angle, and our k there. So what do we do from there? We now solve for what? Now we now solve for k. You remember, it must always be included. It's an element of integers. Now, we now solve for x in that case. We say 90 minus 2x, 2x, and the x will minus each other. Transpose that to the other side. So what I mean in this case is the following. So this means we will now say negative x plus 2x is equals to 90 minus 48 plus k times 360. So in case an element of integers, we also include it here in the space. Then we can now say x is equals to 90 minus that is 42 plus k plus 60. So that is the first solution in that case. Then the second solution, remember the second one, it says our theta is equals to 180 minus our reference angle. plus k times 360, where k is an element of integers. You don't repeat that, you don't forget that. Now what we now do, now our theta, in this case, remember it was 48 and x, then reference angle, that's our reference angle minus 180. Then we solve this, we have 180 minus 90, it's 90, 90 minus 48, it's 42. Then the negative, this one becomes positive 2x. So just solving this one. So what we'll have in that case, we have 48 minus x is equal to 180 minus 19 plus 2x plus k 360. Every statement you write where there is k, you also say k is an element of integer. Now what we now have, we will now have 48 minus x, it's equals to 90 minus x is 90 plus 2x plus k times 360. Thereafter, you will just transpose this to the other side. We have negative x minus 2x, it's equals to 90 minus 48 plus k times 360. What we now have, this side is going to give us negative 3x, which is what we have. Then 90 minus 48 is 42, and it is an element of integers. Then x is equal to negative 14 minus k times 120, where k is an element of integer. So here we're just looking for the general solution. So we just found the general solution as we did right there. We're looking for k. They say simplify sine 3x plus sine x into over cos 2x plus 1 into a single trigonometric ratio. So what we do now, first thing that we do is to break down this, because we don't have it, so we break it down. So 3, it is caused by 2x plus x. So this is 3x. So we solve it like that. Thereafter, what we know now, we know that we can use our compound angles. So it's going to be sine 2x cos x plus cos 2x sin x plus sin x. So this is the compound angle for this one, plus sin x, which is that one, all over cos. Now, where does cos 2 squared come from? So this comes from this, resolving this into double and into the compound angle that we have. Though we have 2, we'll have cos 2x is equal to cos squared x minus sin squared x. Right. Then remember, this is as simple as we can use the square identity here. We'll have cos squared x minus 1. That's what we had in that case. Or we can have it this different way. We can have 1 minus sin squared x. So in this case, what did I do? I wanted to go to cos. So I had here, I had cos squared x minus 1 plus 1, which is this plus 1. So I'm just making it the denominator right now. Then the plus 1 and the plus 1 take out each other. Then you rename it cos squared x. So it's 2 here. So we have 2 cos squared x. So that's where we get the 2 cos squared x from. That's what we get it from. Thereafter, on the numerator, we look at the like terms. So we can see that the sine, there is sine, there is sine. Sine is common. We take sine as common. We remain with 2 cos squared x. Cos and cos will give us cos squared plus cos 2x plus 1. There was a sign here, so plus 1. So this is the first one. We got that. Second one, we got that. Then the third one, we got 1. That is what we have at the end of the day. Thereafter, what do I do again? I now work with this double angle of cos again. I convert it to be like this. So I convert it to be, this is the double angle of cos. So that's the double angle of cos. Then 1 and 1 will take out each other. So from here, what we did here now is we had sine x into 2 cos squared x plus 2 cos squared x all over. So we have all divided by cos squared x. Right. So that's what we have at the end of the day in that case. So what we do from there, we now work with what is in the bracket. So what is in the bracket, we have sine x into, these are the same, so it's going to be 4 cos squared x all over 2 cos squared x. Then what we now have as a solution, we can now see that this and that will cancel out. We remain with sine into 4 sine x into 4 all over 2. Now we know that 4 divided by that is how much? It's sine 2. So this is just 2 sine x, which is what we have as our solution in that case. So from here, this and this cancel out. We add the 2, we have 4 cos squared x. So 4 cos squared x over 2 cos squared x. Then cos squared and cos squared, we cancel out. 4 over 2 gives us 2. Right. Now, let us look at now question 6, grade 12. Now, question 6, I will give you 10 minutes to complete that question. Right, now, let us discuss the solutions to this activity. Now we are told that in the diagram, the graph represents the graph of f at x is equal to 2 sine x, 2x is equals to, and g at x equals to negative cos plus 45 are drawn for the interval x an element of 0 and 180 and lies on f. Write down the period of f. Now let us look at 6.1. Now 6.1, so what we need to look at is the following. Now when we look at f, in this case, our f, the period of f, is f is that graph. Remember when we say write down the period of f, we are looking for the number of times that the graph should repeat itself. So that means this is a one complete graph. So after how long does it repeat itself again? It's after 180. So the period of f in this case is just 180. Or you can just look at this again. You can say y. Remember it's a sine k into x minus p plus q. So when you look at that equation in that case, so what you see now is the following. A, it affects the amplitude and our range. K here, it affects our period. Then x is a horizontal shift. So minus will mean it's going to the right. So the minus p, it means it goes to the right. Then plus p, it will mean what? Left. Then you come back to q. Q is a vertical shift. So plus q means up, minus q means down. So in this case, what we can say, remember the period for the sine and cos is 360. So in this case, it's going to be 360. Then let's check our k. What is the value of k? F at x, the value of k is 2. So 360 divided by k, which is 360 divided by 2, which is how much? 180. And it is true because at 180, that's why we have a single graph and it's going to repeat itself there. So period is how many times a complete graph or function will repeat itself. So it's for that graph to repeat itself. You know, we make how many times? It's just saying where will it repeat itself? It repeats itself after 180 for this one. Right. So the period is 180. Determine the range of g in the interval 0 and 180. So our range in this interval, so what are we told? Remember now, in this g, how we look at our range? We know that g at x is equals to, g at x equals to negative cos into x plus 45. Right. Already we know that this affects our range. However, our range in this case was not affected. This was just a reflection because it's just negative 1. If there's a greater value, our range will be affected and our amplitude. So it will still start at the same point and end at the same point. Now, if we can check, our maximum value is not affected. So our maximum value is still 1. So the graph still goes up to 1 of the g in that case. Now, when you look at the other value that we have, it starts here. So we're going to say this x is 0 at this point. So we're going to say g at 0 is equal to negative cos into 0 plus 45. Thereafter, you solve for the g at x there, which is the y value. So we're looking for this y value in this case. Right. So we're now going to say, because we're looking for the range, so we're now going to say our range, which is y, is equals to negative cos 45. Now, our cos 45 in this case, we now know that it is cos 45, negative cos 45 is negative root 2 over 3. So we punch this in a calculator. Or that is the value that we get for negative cos 45 is root 3 over 2. So this value is root 3 over 2, and this one is 1. So that's why it is negative root 3 over 2. So negative root 3 over 2 is to 1. Now, moving on. In the graphs, okay, determine for which values of x in the interval 0 and 180 for which g at x multiplied by f at x will get f at x multiplied by g at x will get is greater than 0. This is just to say when you multiply two graphs, you must get a positive value. So when are we going to get a positive value in this case? We will get it when we multiply a positive and a positive, and we multiply a negative and a negative. So that is where the two are going to be positive. So negative and negative, positive and positive will give us greater than 0. So greater than 0 means where when I multiply them, I'll get a positive value. Remember, I need to draw my boundaries. Where do I draw them? The sign changes of the graph after the x-intercept. So the first x-intercept is here. I draw the first boundary. Second one is here at 45. We do this and change there. Then we have another one x-intercept here at 90. We have another one at 180. So remember the sign changes at the x-intercept. Now let us check. The first one, so remember, I want to get a positive. This one is positive, this one is negative. Positive and negative gives me the negative answer. I don't want this space, so it's out for me. Look at the second one. Second one is the g at x is positive, the f at x is also positive. So positive and positive will give me a positive answer. So I want this area. Right. Then I proceed. So I proceed. I go to the third one. So what we have? G at x is positive, f at x is negative. When I multiply the two, I get a negative answer. I don't want that. So the only interval I want is between 90 and 45. So what I'm going to say is that x is an element of, so we have 90 not equal to 90, and we have the 45 in that case. So that is the interval where both are not, where we have both of the graphs above or giving us a positive value. Now, 6.3.2, it says f at x plus 1 is less than 0. So in this case, because now there's a value here, what do you do? First thing to do, transpose that one to the other side. You'll have f at x is greater or less than negative 1. So this negative 1 on its own, it is a function. So the function of y, because this is y and y is negative 1 is that line. Passing at a and going to that side. So we just erase a bit here. Right. So in this case we're saying that at this point we're saying take this, say f at x, you just transpose that is negative 1. So this is the different y value. So it's an equation. So it's y is equal to negative 1. When y is equal to negative 1, that's where the line is. Now, we are saying we are looking for where f at x is below the negative 1. So f at x is below the negative 1 at this point. So this is where it is below the negative 1. So it is what? It is from a, from that 105. Remember, this at this point, it will be symmetrical. So it will be symmetrical. So this is, that means this is going to be 105 minus 135 minus 105, you get 30, you get 30. That means from 135 to 3 plus 30, you'll get 165. So the same negative 1. Okay. So that is the same. I'm just going to write it 165 is to negative 1. So that is the point that you say this is symmetrical, and the point is going to be between. So our range in that case will be So it will be between 105 and 165 because it's between this point and 165 there. Remember, symmetrical there, then we get the value as it is there. Right. 6.4. We are told that another graph P is defined by negative f at x. D lies on the P. Determine the values of a in the interval x and 1. So what is happening now is that P at x is the negative function of y, f at x. So P at x, now we're saying minus f at x, we have what? It's negative 2 sine 2x. Thereafter, what do we now do? It lies, or D lies on the points, determine the values of k for the interval x an element of 0 and x is an element of 150. So this one is going to give us a general solution. Now what we do, we substitute D. Substitute point D, which is k is to negative 1. Now, what do we now have there? Our y value is negative 1 is equals to negative 2 sine k, because k is our x value in this case. So, what do we now have? We say arc sine for both sides, then we'll have a reference angle in this case. So, what is our reference angle now? So, we're going to start by saying divide by 2, negative 2, divide by negative 2. Then what we have sine k is equals to 1 over 2. So our reference angle in this case is gonna be reference angle is equals to arc of 1 over 2 is 30. Now we're gonna apply the general solution of sine. And we're just gonna come up with the solution. Solutions are correct by the way. I'm just gonna need the space there. Now, how did we get to that? Remember, sine, the first one is theta is equal to reference plus k times 360, where k is an element of integers. And the second one is theta is equal to 180 minus reference plus k, where times 360, where k is an element of integers. So in this case, we're now saying our reference angle is k is equals to 80. That means in this case now we'll now say let me just see that the k is 2k here. 2k. So 2k is equals to, so our reference angle here is 2k is equals to 80. That's what we have here. So this is our theta, this is our reference angle. Now it's equals to 80 plus k times 360. That is the first one. Or 180. We have 2k. So the 181 is equal to 180 minus 80 times. So we multiply by k times 360. Times 360. So what we do here, divide by 2, divide by 2, divide by 2. Then what we now have is k is equals to, this is how much? 80, so it's 15. 50 divided by 2 is 15. 15 in that case. So we are saying with k, here it's going to be 15 plus k times 180. Then or second solution, divide by 2 again. With k equals 180 minus 80 is 150. 150 divided by 2. Divide by 2 both sides is equal to 75 plus k times 180. So that's those are the solutions we have. So I write them nicely here. With k is equal to 15 plus 180k. Then the other one we just leave it on other space. Now, so what we do from here, we now check k is an element of integers. When you substitute k is equal to 0, we check if it's going to fall within the range. So when you substitute k is equal to 0 here, we get 15. 15 falls within, we accept 15 is correct. We continue, we substitute 1. When you put 1 under 180, It's going to be k plus 180 plus 15, which is above 180. We don't want it. Then we go and check the second solution. The second solution where k is equals to 75 plus k into 360. When you substitute k as 0, we get 75. So 75, it is within the range. Then when you proceed and say, okay, let's now substitute k as 1. So 1 plus 360 times 3 is 360. Then 360 plus 75 is way above the 180, which is not what we want. Now let's go into the negative values. When we substitute a negative value here, we get negative 180. Negative 180 plus 15, we get a negative value. We don't want a negative value, we want from 0. Even here, when we put a negative 1, we get negative 360. Negative 360 plus 75 is a negative value, which is not within our interval. So what is within our interval is when I substitute k is equal to 0 in both of these equations. That's what I get as both values. Now, 6.5. Right, they said another graph P is obtained when G is translated 45 to the left. Remember, where is P? G and X. Now remember that G and X is equal to negative cos into X plus 45. So we're saying it is what we normally saying from our standards, Y is equals to A cos K into X minus P plus into plus Q. So plus Q there. This is what you call a horizontal shift, which is the one that we're talking about there. So when it's plus P, it means to the left. When it's minus P, it means to the right. Now let's come back to this. So it's translated to the left. So when it's translated to the left, it means plus 45. So that means in this case, from our equation, we will now say J at X is negative 45 plus that, we quote it down. Then we're now going to come and say, okay, from that J at X, then H at X is actually equal to negative cos into X plus 45 plus another 45. Because to the left, it means plus 45. So now we have negative cos into 90. Then X plus 90. Then we have negative cos into X plus 90. Then we know that we go to our Cartesian plane and say, okay, 90 plus, it means cos is negative. So we are supposed to be having a negative sine, this is just equal to H and X, negative sine. So we are saying, I'm repeating now, we are saying from a Cartesian plane, X plus 90 is here. That means cos is negative. So that means our sine, as it changes to sine, it will be negative that we have already there into negative sine X. Then it becomes positive sine X, which is what we have as our final answer. So that's what, and that's all we have for that. Now, question 7. Now, question 7, we're told that in the diagram, S, T, K, and lie in the same horizontal plane. RS, the vertical tower, the angle of deflection from R to K is beta, TSK is alpha, and TS is P, and the area of triangle STK is Q meter squared. Determine the length of SK in terms of P, Q, and S. Now, how do we find that those two? So we are given the area. So the first thing that we do in this case, we are given the area. So the area is half base times height. So we are told that this is P, the area we have it, which is now QM squared. Then what are we supposed to do? We're supposed to calculate for SK. What are we going to do? We're going to use the area of STK. It's equals to half base, so our base. So this is our base, which is what? It's going to be area of a triangle STK. It's equals to half base. Our base is TS. Then another one is SK times included angle, which is sine alpha. So this is the included angle. So now in a space of TS, we now know TS is equal to what? It's P. So you substitute P in the space of TS. Our area is Q. You substitute Q in the space of area. Then we now solve for SK. We divide by 1 over 2. We divide by all of that. We divide by that. So that means we'll have Q is equals to 1 over 2 P into SK sine alpha. So we divide by 1 over 2 P sine alpha. Then we do the same, so 1 over 2 P sine alpha. Then that cancels out, this cancels out, this cancels out. Then SK is equals 1 over 2 P sine alpha. Then you just reciprocate this. Then you get 2 over that. And that's our SK. Now, number 2. Show us RS. Let me just go back a bit. Show that RS is equals to 2Q tan B over there. Remember that our SK equals 2Q all over equals all over P sine alpha. So we had SK already. So what are we looking for? RS. So RS is this side. We're looking for that pole. So to find that RS, what can we do? We know that the angle of depression is equal to the angle of elevation. Then this is beta. Why? Because these two lines are parallel. When they are parallel, they give us alternate angles. So that is an alternate angle that we are getting from that. So that is the same angle. So we're saying those two now are the same because we're getting an alternate angle out of that. Thereafter, which trick can we use? We have that. We are looking for that. We can use tan. So in that case, we can just say tan beta is equals to RS all over SK. Right. Easy. Now, tan is equal to RS over to SK. Now, what is SK? So tan beta is equal to RS all over. Our SK was 2Q into sine alpha, P sine alpha. Then you cross multiply. Then you find that RS is equals to, when you cross multiply there, over 1. When you cross multiply is 10 beta is 2Q tan beta over RS. So that is how we get our SK in that case. Or the second option, we can use the sine rule. So when you're using the sine rule, let me just look at the solution of the sine rule. When you are using the sine rule in this case, what are we going to do? So we have beta here. And we'll know that this is angles in a triangle add up to 180. So this will give us 90 minus beta. So in using a sine rule, now we'll say RS, which is this one, over sine beta, so that one, is equals to SK, is this, over sine of 90 minus beta. Now, 90 minus beta already is cos. So cross multiply, so this is already cos. That means we had RS over sine beta is equals to SK all over cos beta. So that's what we had in this case first. Now, what we now do, when we cross multiply, we have RS cos beta and we have sine beta times SK. Then RS cos SK tan beta. Then we substitute the value of SK in this case. So our SK, when we substitute it, then we have SK. So from that point, we have RS is equals to, our value of SK was 2Q over P sine alpha. Then this is multiplied by 10B. Then that's what we have. 10B multiplied with that, then we take that as our RS. Calculate the size of theta if RS equals to 70 meters, P is 80, and Q is 2,500, and P is 42. We just use the RS that we found. So this was RS. So we used RS, it's equals to, so our RS in this case is equals to, the RS it was equals to 2 P, it was 2 not P, it's 2Q 10 beta all over, it was all over P sine alpha. Can you just substitute the value? to say RS we're given is 80, 70, we put 70 as RS. We are told there's 2, okay, there's Q is how much? Q is 2500, we put 2500. Beta is 10, beta is 42, let's put 42. Then P is your 80, so we're told that P is 80, then sine alpha is it's just alpha in that case, so we're looking for that alpha. Then thereafter we just press everything like this in the calculator, we get that. Then we solve for sine alpha, then add sine alpha both sides, we get A equal to 0.7. Now next lesson, in our next lesson, grade 12, we'll focus on analytical geometry. So this will have question 3 and question 4, and we'll also look at Euclidean geometry, which is question 8, 9, and 10. Thank you. Enjoy the rest of the day.